Hi. In the last session, we had some understanding of how the deployment of machine learning models works in the open network systems. Now let's talk about some of the use cases of the machine learning models and its deployment in the open network systems. So machine learning models not only used for optimizing the network on the current situation, like based on the current feedback and the network conditions, but it can be used for predictive planning of the future network utilization and optimizing the resources to handle those future predictions so that sudden change in the environment will not affect the user experience and network KPIs. Machine learning models can predict the utilization based on the trends and the history, and accordingly it can decide to add up more resources to the specific cell and site from the pool. Or kind of traffic balancing, it can also plan between the shared cells and sites. Machine learning model can also be used for automatic network designs. They can predict the ideal locations for future cell or site planning, depends on the coverage gaps or the capacity gaps, etc. In another use case, machine learning models can be used to solve the network problems by their own without direct human interventions. These machine learning models are capable for fine-tuning the parameters in live network, and that too in the loop of feedbacks and actions. Means the network will optimize in the current network conditions. Another machine learning model which can be developed using the machine learning is identifying the fraud detection, where different kind of rerouting and other techniques gets used to bypass the original services and uses backdoors to get the services from the telcos, which hampers the overall revenue of the telcos. So the machine learning models can identify those users in the network and blocks their bypasses so that the right revenue can come in the stream. Machine learning models can also deploy in solving the customer issues if the reported issues by the customer is generous, like the amount is detected without being using the services or even demand of service. So the machine learning models can take the information from the network history and may take the optimal decision from the telco perspective and customer perspective. So these are some of the most commonly discussed use cases in the market which can be integrated in the open RAN network systems with the help of machine learning models and intelligent applications. Now let's talk about one example in details. Suppose the requirement is to develop a model for traffic sharing between the cells or sites in the open network based on the resource utilization. This traffic sharing can help improving the user experience as well as the network KPIs. So this is the Open RAN architecture with real-time rake and non-real-time rake. These are connected to the OCU and ODU and serves few cells or sites in some geolocation area. So we considered 3 cells at 3 different sites which are connected to the OCU and ODU in the same pool. There are some users connected with each specific cells and actively using the services like downloading, uploading, voice call, etc. Here, non-real-time rake is collecting the data from the ODU like signal strength, signal quality, radio conditions, resource utilization, number of users, etc. By collecting all these information, radio intelligent controllers knows that some of the cells are overloaded in the terms of resource utilization and number of users, and some of the users which are in good radio conditions with the neighbor cells can be shifted from the overloaded cell to the less loaded cell. If you compare it with the traditional network system, then this performance data is very specific to any cell or site, where individual cell or site gets analyzed for its performance, but with Open RAN system and with virtualization and cloudification of network, where the common resources are shared between the multiple sites and cells in the pool, it has the wider picture in terms of data visualization. Hence, the real-time rake and non-real-time rake are in better position for decision making because it has the data of all the users connected to all these 3 cells in one pool. So based on these user information and cells performance information, we'll take a decision to allocate the more resources to the overutilized cells so that user requirements in terms of resources can be matched. So it will allocate more resources from the pool to that cell. In this deployment system, you can say that more resources will add for the DU of cell 2 through the real-time rake. So we have E2 interface between the DU unit and near real-time rake. Real-time rake sends this information continuously to the DU for the traffic steering and resource scale up or down. Non-real-time rig and real-time rig are connected with the O1 interface, where non-real-time rig gets the feedback on the control functions and mobility management. Let's talk about one more use case quickly. This is quality of service and quality of experience for the use cases where the bandwidth and latency both are important, such as the example of augmented reality and virtual reality, which requires lots of data transfer for high resolution video streaming and also high latency to get the real-time responses on the actions. So the responsibility of rig is to allocate the sufficient resources to serve the good user experience, and for this, real-time rig required to monitor the performance and the resources requirement continuously, like buffer state, downlink and uplink PRB uses, throughput, latency, radio conditions, etc. And this data can be measured from the different nodes like OCU, ODU and real-time rig. All these information will be feedback to the machine learning model, and based on that, the machine learning model will take the appropriate decision to maintain the right QoE or QoS for the user. In the next session, we will be talking about RIG, Radio Intelligent Controllers and machine learning model deployment. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video and don't forget to share. Thank you for watching.